Hello, Math 7. So we are looking at percents and prices, lesson 5 today, markups and discounts. So we've been talking about markups and discounts for the past couple of days, and we did problems with just discounts and problems with just markups. And now we're looking at some that have both a markup and a discount. And then we always want to make sure that we apply those in the order that it tells us to. So big question today, so focus question, what is important to remember when you have to apply both a markup and a discount to the price of an item? So number 1, Bennett bought a $21 meal. The sales tax was 5%. Bennett tried to find the sales tax in a few different ways. Which of these methods are correct? Of the correct method, which makes the most sense to you? And explain. Alright, so let's look. And whichever one makes the most sense to you, that is up to you, right? I can't tell you which one makes the most sense to you. So, part A, or option A, 5% sales tax means that for every dollar you spend, you need to pay a nickel in tax. If you buy something for $21, you need to pay 21 nickels in tax. So do you think that's right? So let's think about that. So 5%, and remember percent means per 100, so 5 out of 100 would be 5%, and so they're saying 5 out of every dollar you would need to pay 1 nickel, so you'd need to pay 5 cents. I think it might make sense, right? So 5% per 100. So then how much would we need for $1? Yeah, so it looks like A is right. Okay. B, you can set up a proportion and solve for the missing value. So 5 cents for every dollar, so x over 21. Yep. And then we can see that the scale factor here, 1 to 21, is times 21. So then we'd have to do 5 cents, also times 21. So that one works too. Option C. I know that 10% of $21 is $2.10, so 5% would be half of $2.10. So let's see, is 10% of 21 210? So 10 over 100 equals x over 21. If we do our cross multiplying, we're going to get 100. Whoops, 0 didn't go. 100x equals 210. Divide both sides by 100. And remember, you can always use your Desmos calculator. So let's pull that up and do 210 divided by 100. 2.1, or when we're talking money, 210. Okay, so then does that make sense that 5% would be half of that $2.10? Yeah, because 5% is half of 10%. So part C works. Well, not part C, option C works. Okay, 5% is equal to 1 over 20. So to find the amount of tax on $21, find $21 divided by 20. Let's see, does that one make sense? So it's saying 5% is equal to 1 over 20. So let's go over here and say, okay. So it's saying that 5 out of 100 is equal to 1 over 20. So we're asking, is it equal? Well, 20 times 5 gives us 100. So 1 times 5 gives us 5. So yeah, that's equal. So we would want to know what, 21 divided by 20 would also work. All right, so part D also works, or option D. All right, option E, 1% of $21 is 21 cents. So 5% of $21 is 5 times 21 cents. Well, that would work, right? Because 1%, and we would just need to do that 1% 5 times. Okay, so they all are correct. Which one made the most sense to you, though? So that part is up to you. So all are correct. But then you pick which one makes the most sense to you. And explain why you think it makes the most sense. All right, Sandy purchased a coffee mug at Target for $19.95. She uses her Target Red card, giving her a 5% discount. Then, a 7% tax is applied to her total. What is the total price she has to pay after the discount and tax are applied? Okay, so she first uses her Target Red card for the 5% discount. So we're going to start with doing 5% of the $19.95. So 5% of $19.95. So 0.9975. So because we have to round, we're rounding to the nearest hundredth, and that's a 9 there, but next to it is a 7. So that would make that 9 go up to a 10, which would then make the 9 there going up to a 10. So we're actually going to round that up to $1. Okay, so she gets $1 discount, which means we're doing $19.95 minus $1. So $18.95. And so then we also have to do tax, a 7% sales tax. So then now we're finding what is 7% of $18.95. So you can use our trusty calculator again. 7% of $18.95. That gives us $1.33 because we have that 2 there in the hundredths place, and that 6 tells us we have to bump that 2 up to a 3. So $1.33. So then this time, tax is a markup, so we have to add. So $18.95 plus $1.33. So we get 20.28. So our final price or our final total is $20.28. So now we're at the top of page 37, and so we're on example number 3. A store purchased a binder for $3.20. In order to make a profit, they put a 55% markup on it. However, they were not selling well, so they had to discount the binder by 20%. What is the current price of the binder, and how much does the store make from the binder now? Okay, so do you think we could do 55 minus 20 and then just say, oh, so it's only 35% more? So then we just find the 35% of the $3.20, and then that's our answer? No, because we have to know how much they were selling it for and then take the discount off of that. So they were marking it up 55%. So 55% markups. Remember, markup means that we're adding. And then they discounted it 20%. And so discount, subtract. So we have to do the markup first. So we are finding 55% of 320. Whoops, my decimal point didn't go. There we go. So $1.76. So 1.76. So it's a markup, so we have to add. So 320 plus 1.76. So $4.96. So that was the price. $4.96 was the price they were selling them for. Okay, so it wasn't selling well at that $4.96 price, so they had to discount it by 20%. So now we are finding 20% of the $4.96. And so we get 99 cents, 0.99. So it's a discount, so $4.96 minus the 99 cents. And so that gives us $3.97. So their current price that they're selling them for is $3.97. Okay, but then also, so we had two questions. What were our questions that it was asking? So what is the current price of the binder? Okay, we answered that question. How much does the store make from the binder now? So we have to figure out how much the store is making. All right, so they're buying it for $3.20, and their current price is $3.97. So we have to do $3.97 minus the $3.20. So the money that they're making on each binder is 77 cents. Okay, so we answered both questions. So the current price of the binder and how much money was made on each binder. Alright, so next one. Example 4. Your total at a restaurant is $46.76. First, you are taxed 8%. Then you choose to tip 20%. How much money will you end up paying? So this is one of those that it tells us first you are taxed 8%. So it tells us that we're doing that tax first. So we're finding, and the tax is 8%. So we are finding 8% of 46.76. So 8% of 46.76. So $3.74. Okay, so that's the amount we're being taxed. So then the tax is a markup. So we're going to be adding. So 46.76 plus 3.74. So we get 50/50. Okay, but we're still not done. So that was our tax. So first we were taxed 8%. Then you choose to tip 20%. So now we have to find 20% of the 50/50. So 10.1. So remember it's money, so we don't say 10.1 cents, right? And that wouldn't be $10.01 because we need another decimal place. It's $10.10. Okay, so tip is another type of markup, so we're going to be adding again. So 50/50 plus 10/10. So then we get 60/60. So our amount paid $60.60. Okay, so first we found what our tax was, and so we added that to our total. Then we found our tip amount, and then added that to our total. So we got our final total with our tax and tip. Alright, so now we're on the top of page 38 and ready for example 5. So David was shopping for a particular book. The best online price was $10.99 with a $2.99 charge for shipping, and there was no tax. Given a 6.5% local tax, what price before tax does David need to find at the local bookstore to get a better deal than he found online? Okay, so first let's see how much would he pay for online, because we need to know what price we have to beat. So you can buy it for $10.99 with $2.99 for shipping. Okay, so $10.99 plus $2.99 for shipping. Okay, so the online price is $13.98. So whatever price he finds at a local bookstore, it needs to be less than $13.98. So this one we kind of have to work backwards. So we know his total, and then we know how much. Well, we don't know the total. We know that the whole percent that he would be spending would be 100%, right? Because that'd be the full cost. 100% of what he was buying. Plus 6.5% more of that for the tax. So let's think about it that way. Right? 100% for the price of the book. Plus he would have to do 6.5% more for tax. So he was going to be paying 106.5% of the price of the book. So we want to know if $13.98 is our price to beat. So let's use that. So $13.98 is our price to beat. So we want $13.98 is our whole. I put that a little too close. Let's move that down. So $13.98 is the whole, and we know 106.5 is our percent. Or no, hold on, I did that backwards. Nope, $13.98 is the part. I apologize. Whoops. $13.98 is the part. We want to know what the whole would be if his absolute total was $13.98. Alright, so there's our proportion. Sorry about that. So x times 106.5 gives us 106.5x. 1398 times 100 gives us 1,398. Divide both sides by 106.5. So we're left with x on this side. So 1,398 divided by 106.5. So 13.127, but it is money, so we do need to be rounding to the nearest hundredths place. So that 7 tells us to round that up. That 2 to a 3. So $13.13 would be the largest price that he'd be able to find a book for. So let's kind of write that out. So David needs to find a book for $13.13 or less. Better deal. Okay, example 6. After Halloween, supermarkets put Halloween candy on sale. The first week after Halloween, the manager marked the candy down 40%. The second week after Halloween, the sale price was marked down another 30%. If you visit the store during the second week of the sale, and the bag of Halloween costs $1.34, how much did the bag of candy originally cost? Okay, so it was marked down twice. And we need to make sure that we listen to the hint. So the hint says the total discount is not 70%. So we can't add those two together and then figure out what our total would be. But we kind of have to work backwards. Okay? So they first marked it down 40%, and then they marked it down 30%. So that means that this $1.34 is after the 30% discount. So we have to use that 30% discount first. And so remember, we're finding their original. So finding the original, so we know, if we set up our proportion, we know 100 is there for our percent. We know that $1.34 was the part that we found. We want to know how much did it cost before the discount. And remember, when you're finding the original cost, you have to do 100 minus whatever the discount was to then find the percent of the total your part is. So that is 70% of our total. Okay, now we have a proportion. 70 times x gives us 70x. 100 times $1.34 plus 134. Whoops, that was not the right place. Divide both sides by 70. Left with x on this side. And then 134 divided by 70. We get $1.91. Okay. So then after the first markdown, it was $1.91. So now we have to look at the 40%. So it was marked down 40% from the $1.91. So we can set up a similar proportion, except for this time we have to do 100 minus 40. So our total is 60% of the original. So 60 over 100 equals $1.91 over x. So that's what we're trying to find. 60 times x gives us 60x. 100 times $1.91. So that's 191. And then divide both sides by 60. We get 318. So our original price of the candy was $3.18. All right, so let's answer our focus question. What is important to remember when you have to apply both a markup and a discount to the price of an item? Well, the biggest thing we know is that order matters. The markup and discount cannot be added or subtracted from one another. Alright, so this has been Percents and Prices Lesson 5. Don't forget to do that daily practice. I will see you guys all later. Have a great day, Math 7.